the speakers up to now have been sort of taking you into the future. I'm going to sort of take you back to the past now, about maybe 40, 50 years, because that's when I first met Bucky. And a lot of what I'm going to be saying is sort of written out here in an article I wrote for the Encyclopedia of Architecture, Design, Engineering, and Construction, John Wiley, back in 1988. But anyway, to sort of go back in history, I went to school at Cornell, class of 54, a couple of years after Bernie was there. And the School of Architecture had a visiting critic program. And in 1952, I think it was, Bucky came by, and he was the visiting professor for my class. And the project we did then was what's now called the geosphere. We built a 20-foot diameter replica of the Earth out of lath, copper screens, and chicken wire. And I'd just come out of the military myself back then, and I was in a topographic battalion, so I had some knowledge of cartography. So I became kind of one of the leaders of the various project groups that get organized on a Bucky project. When Bucky went to a university, he would first of all spend maybe, I don't know, a couple of days just sort of talking and rambling and getting the students sort of in tune with his thinking. And he would then, once the project was identified, organize the students into groups. There had to be a research group, a mathematics group, a PR group, a purchasing group, because what we would do is we would actually do a project and really sort of interact with the real world. And I remember at Cornell we got material donated by various lumber yards and hardware places. We got the student publications and newspapers in the local area involved in what we were doing. Bucky was at that time in touch with various research departments of the Fortune 500, because he used to be he was the editor, I think, of Fortune magazine back in the 40s. So having all these contacts and sort of using the way that he would sort of use the project to sort of promote, and get interest in what we were doing at school, by utilizing this team method, he got us organized into a very efficient sort of a working group. The geosphere, as I said, was this 20-foot diameter sort of representation of the Earth, and I was in charge of the group that actually took the cartographic information off of a sphere and put it onto this 20-foot diameter wood lath and chicken wire and copper screening sphere. The basic background was the hexagonal chicken wire. And what we did was we cut out the continental land masses out of the copper screening and placed it, exactly on the sphere. And I did most of the layout work on that to sort of make sure that everything looked correct. The outgrowth of that project was that was at the end of my school year, and that summer I went to New York to work in an architectural office. And Bucky was also in New York working on it was the Ford Rotunda Dome at that time. And he was working in George Nelson's office, working on the Rotunda Dome. And I'd go by and see him in the evenings, and he decided that I have to take you back a little bit now. He had earlier in the 40s done a Dymaxion air-ocean world map, his world projection. At that time, he projected the information onto the cuboctahedron, squares and triangles. Subsequently, he found out that it was much better to use the icosahedron. So he wanted us to use an icosahedral projection of the Dymaxion air-ocean world map, and that's what I worked on in 1954 evenings in New York with Bucky, and so. That culminated in 1954 in the North Carolina Student Publications actually publishing the Dymaxion air-ocean world map. And that was I graduated from Cornell went down to his office in North Carolina, and while I was doing that, the office had been set up in North Carolina, I think maybe about a year earlier. Bucky had essentially two offices, one in Cambridge, Massachusetts. Bernie was part of that group, and one in Raleigh, North Carolina. I was part of the Raleigh, North Carolina office. The separation was based on the Cambridge office working essentially on the Dew Line project, which was quite a big project with Western Electric at that time. And the office in North Carolina worked on lightweight shelters with the Marine Corps. And we worked on magnesium domes, aluminum domes, hub and strut, and vinyl-coated nylon tents, helicopter liftable sort of structures that would be airlifted off of the deck of an air carrier or used in wartime for emergency shelter for aircraft or for personnel. That was in the early mid 50s that this kind of development was going on. I think the geodesics operation continued for quite a while and also transformed into another organization called Geometrics, which Bernie, you can say more about why that transition, or why there was another organization formed besides geodesics. I think it was wanting to go into another area besides working on radomes or something like that. Anyway, we tried to get into more of the ordinary line of architectural sort of work rather than working for large corporations like Western Electric or for the military. In Cambridge, it changed to Geometrics. In North Carolina, we set up another firm called Synergetics. And Synergetics worked on non-military projects. And back then, Bucky had a lot of publicity, and we worked on a lot of projects, but many of them were studies, theoretical sort of visionary kinds of things that would come in, and the only project that from that period that I was involved in that really was built and made quite an impact was the dome that we built on about a 1 month notice, I guess it was. This was back in 1953, I guess it was, when there was no, I'm sorry, that would be 1955 around. There was a trade fair going on in Afghanistan. And at that time, the U.S. Trade Department, or whatever it was called, needed to have a structure and an exhibit put up in Kabul, Afghanistan, to show U.S. presence there. And the guy in the USIA who was in charge of that used to be a former student of Bucky at Yale University, Jack Macy. He called up and said, Bucky, we have to have this kind of structure there, an exhibition structure, in a matter of a month or so, and it's got to be put up in 5 days. You think you can do it? And Bucky, of course, says, sure, And of course, he, and the budget, is going to be so much, I forgot what it was. And Bucky said, sure, we can do it, And the thing with Bucky was that he was always very optimistic about what the project would cost. And but Jack was, I think, sophisticated enough and knew enough about Bucky to sort of put in the Bucky factor. And I don't know what the Bucky factor at that time was, but I've heard, jokingly, he would say 10 to 1, If Bucky says it's going to cost, so much a square foot, just multiply it by 10. Anyway, this was one of those kind of impossible projects, and we were able to do it. We were able to the other requirement was that it had to be airliftable and fit into a 1 DC 8, I think it was, or was it a DC-4? I can't remember now the exact designation, but it had to fit into one cargo aircraft, be able to be flown to the site, and put up in 3 or 4 days by untrained sort of personnel. And we were able to put up this 114-foot geodesic dome And it was the hit of the show there because the dome shape, the yurt, I guess, but yeah, he called it a yurt, was very familiar to the natives there. And so it really caused quite a sensation there. And subsequently, that dome was used by the trade fair office for other trade fairs. And many years later, Bucky said that this is the first building in history that's flown around the world because it went from one trade fair to another. The USA kept using it, and so it's an example of, a lightweight structure really performing, a lot of functions. So that took us into, 1956 or 8. I subsequently went on a Fulbright to Japan, and when I came back, they had just completed the down in New Orleans, the dome there for Union Tank Car. And this was another one of those amazing projects where this was, a dome that was used for tank car repairs. And the dome shape was ideal for a tank car repair house. And that was about 380 feet in diameter. The project that I was really most intimately involved with was 1967, the U.S. Pavilion. And that was quite a dramatic turn of events because originally, when the USIA came to us, they wanted, again, it was Jack Macy who was in charge. He told Bucky, there's this, Montreal is going to be a big exposition. The Soviets are going to be there. We want to really come up with a structure that's really going to be significant. Do you think you can do it? And of course, he said yes, and he gave another estimate then, and fortunately, we were able to meet the budget. But the first schemes were for a huge octet space truss that was going to be up about, raised up above, maybe about 60 feet in the air, about the size of a football field. And down below was going to be the Dymaxion Air Ocean World Map. And it was supposed to be full of miniature light bulbs, and it was supposed to be controlled by a computer program, and you were supposed to be able to play world game. The whole idea was there would be a gallery at the top. You could look down on this, and by using some software that was still not developed, be able to maximize, minimize certain sort of resources in the world and see what effect it would have. And the whole idea was to try to make the world a success. But this, of course, the technology wasn't there. You couldn't possibly build it for the kind of money that they had. So in the end, they said, well, let's do a geodesic dome. We didn't want to do a dome because Bucky was known as, for geodesic domes, and we wanted to do something quite different. But in the end, we settled on the dome, and that turned out to be the 250-foot diameter U.S. Pavilion. I think that we made quite an impact on the exhibition world because I think subsequent to that exhibition, every other World's Fair that I've seen had some kind of a dome or a spherical structure in it. In '67, it made quite an impact in Montreal. The people who came to us at that time from Montreal, the World's Fair, said that one of the program requirements that they'd like to have is for the mini rail to be able to go through all of the pavilions. And I think most of the pavilions tried to comply, but I think ours was the only one where the mini rail actually went right straight through the pavilion. And I don't know how many of you, went there, but you did.
I was 7 years old.
You was
Amazing.
Yeah. And we had, the mini rail was up fairly high, and you came in at the equator, which was must have been about 60 feet up in the air, and you went right straight through the dome, and you could look right and left and see all the exhibitions and sort of go out the other end. We were successful in doing that, so I thought that, with the impact that the U.S. Pavilion had in the architectural world and the press and all that we would be inundated with, architectural orders and commissions. We waited and waited, and, we kept answering the telephone, in terms of various projects inquiries that came in, but really there was only one more project that we did of that nature, and that was the Southern Illinois University Religious Center. the kind of people that seemed to be attracted by what Bucky was saying were the hippie world, I guess you would call it. This was back in the 70s, and I remember in the office, these people would come in very serious, and one particular guy, I remember coming in, he had a commune just outside Boston, and he said he's interested in a geodesic dome, about 60 feet in diameter for his group, and he said that, we said, what kind of structure, what kind of skinning and framing, and he said he'd leave that up to us, but he said one requirement we have is that at the base of the dome, where you enter, where you have these triangular openings, make sure that none of those have any kind of material on them, either glass or metal. I said, why? It's going to be cold. How are you going to control things? He said, well, during meditation in our group, some of our group levitate, and so we have to be able to sort of float out without any obstruction. So those are the kind of inquiries we got, and so that we survived by doing all kinds of projects and visionary things. Another famous or one that resulted in a fairly dramatic model was the floating city project. This is back in the 70s when there was a lot of talk about development of urban development in the larger cities, and the problem always was finding land that was available and close to the centers and at a reasonable cost. And so we did a cost study and did some projections at that time, and it came out that it would be technically feasible to, that it would be feasible to build floating cities near large metropolitan areas where we had about 5,000 inhabitants in a module. And it was economically feasible to do that at that time because the costs came in fairly low per square foot. But the one thing that the engineers could not solve was how to sort of anchor or hold the floating module in place in case of a hurricane. And of course, Bucky had originally conceived of these floating cities as being autonomous in the sense that he was projecting it to be, atomically fueled and desalination for salt water. And so if a hurricane was coming, you would just sort of go out to sea and ride the storm out at sea, as most large vessels do. But this was not feasible or not possible. So we did some interesting studies. I made a big model that was about 3 feet across and about 2 feet high. And this was during the Johnson administration. The model is now at the Johnson Library in Austin, Texas, I understand. I haven't been there to see it myself, but that was one of the last big projects that we did in the office. The architectural portion of the firm that we had formed, Fuller and Sadao, that was the last sort of significant project. Oh, I should mention one more. The other project was a theoretical study for a tower that's going to be higher than Mount Fuji in just outside Tokyo, Japan. And this was, again, a very wealthy Japanese individual who was the owner of the Tokyo Giants, the Yomiuri newspaper, which has the largest circulation in Japan, and also a racetrack. And he had a fairly large amount of money, and he'd heard about Bucky. And originally he heard about Bucky because he wanted to build the first domed stadium, baseball stadium in Tokyo for the Yomiuri Giants. And we went there in the 60s and did some studies. And one of the studies that Bucky developed at that time was what he called the suspension dome, which was a rising suspension. And at that time, it was not received too well by the contractors or by the client in Japan, but Bucky did take a patent out on it, and subsequently the expansion dome was used by Matisse Levy at Weidlinger Associates to put up what's called the Georgia Dome now. And he said to me actually that it was only possible to do the structural analysis of the dome, once computers came into being, that he could understand why Bucky wasn't able to convince engineers to do that back in the 60s. But Mr. Shoriki, wanted to do this dome, but since he couldn't build that, he asked Bucky to build this large tower. And again, using the firm that Bernie was with in geometrics and ourselves, we did a feasibility study and hired some engineers to do other studies with it. And again, I think the result was, in this case, technically feasible, but economically not. And so that was another one of these visionary kind of projects. So the firm still exists. We still have Fuller and Sadao. I'm working on quite a few. I did work on quite a few non-geodesic related projects. What I'm working on right now is going to be with the Stanford University libraries, where the Fuller family sold the archives to Stanford University, who are now cataloging, preserving all of the artifacts and the manuscripts that were in Bucky's collection, the chronophiles, which are really a tremendous sort of repository of information of what Bucky did and what he collected during his lifetime. What we're planning on doing is having a major U.S. exhibition on Bucky, which has not really taken place here in the U.S. We were successful in getting a European tour the last couple of years that traveled through Europe and then through Japan, but that exhibition did not travel through the U.S. The material is now with the Stanford libraries, and we're trying to organize an exhibition that'll commence, we hope, in a major museum in New York, and travel through Europe and travel through Asia. But that's going to take quite a bit of doing, and it's about 3 to 5 years down the road, and we're just now at the fundraising phase, and that's going to take quite some fundraising to get enough money to do a real significant Buckminster Fuller show. But we're actively working on that now and hope to have it going within the next 3 years. I don't know, I guess that's about all I can say right now about the past. Hopefully in the future with this exhibition we'll be able to generate enough interest back into Bucky and his environmental concerns, so that I think Bucky has a more important role to play in our lives, and maybe by doing this and getting the exhibition going, we'll be able to stimulate interest back into Bucky's thinking and the kind of ideals and visions that he had. So anyway, that's all I have to say. Thank you very much.